Hi everyone, I'm Sky Weston and in this tutorial series I will be making a basic FPS controller as well as a weapon manager with which we can do basic stuff like switching weapons, picking them up, etc. And finally I will be creating a wall running mechanic which as of now is not very polished, but more on that later. For part 1, that is this video, I will create a basic FPS controller with which we can look around, move and jump. I will start by setting up the game world, though I will going to fast forward this part as I assume prior to watching this video you have a basic understanding of working in Godot and its 3D interface. So if you want, you can go straight to the timestamp shown on the screen where I began creating the player. Or else, if you want, you can see the way how I have set up the scene. Now I will create a new scene for the player, then add a kinematic body as a root. Now I will add a mesh instance and set its mesh to a capsule. After doing this, I will align the capsule to the general orientation of the player by rotating it by 90 degrees around the x-axis. Finally, I will do some adjustments to the shape in order to set its height to around 1.75 meters, which is just to stay consistent with the real world proportions. And also move the mesh instance up a little bit so that the bottom of the capsule touches the origin. Now add a collision shape, set its shape to a capsule, and change its parameters to the same values as that of the mesh instance. Now for setting up a camera, I will add a spatial node. Name it anything you feel like. I will name it cam root. Then add a camera as a child of it. Just make sure when aligning the camera, don't move the camera itself. Move the cam root node instead, as the position and rotation of the camera should remain 0. Now save the player scene and add a script to it. Now I will create a constant variable for the mouse sensitivity. So first of all, before we do anything, let us better understand how the player scene is set up. As we can see, the camera by default points in the negative Z direction, which makes things kind of confusing, but I recommend to keep it this way only. So from now on, if we have to move the player forward, then it means we have to go in the negative Z direction with respect to the player. Now to look around, we will first do a vertical rotation on the camera root node. We will rotate it around the x-axis and make sure to convert degrees to radians. After that, we get the mouse position relative to the last frame times the mouse sensitivity. As the mouse relative position gets returned in 2D space, so the y value is positive downwards. So we will have to multiply the result by -1 since the rotation increases when we want to move the mouse up. Similarly, we will do the same thing with the horizontal rotation, but this time on the player node itself. We will rotate it around the y-axis, convert degrees to radians and multiply the result by -1. And that's because our rotation around y increases towards left. Now in the input function, let's perform the camera rotation. Now let's add player scene to the world scene and place it somewhere over the ground. As we can see, we are having some trouble moving the mouse around. To fix this, we will have to set the mouse mode to capture. But then in order to make the running window inactive or just move it around for debugging, we will need to make the cursor visible too. So to make our life a little easier, let's create a function to handle the window activity. By the way, this is temporary and will later be replaced by a pause menu. The mouse movement feels much better now, but you might have also noticed that we are able to rotate the camera infinitely around the x-axis, and that is something we don't want. To fix this, we simply have to clamp the rotation of camera root. I will go with 75 degrees, but you can choose any value you feel like. As we can see, the camera movement works much better now. Now let's do the player movement. Now let's override the physics process function. But before we go any further, let's create some actions we will need for the user input. Now let's declare some variables. I will first get a reference to the camera node, which we will use for getting the direction. Then I will declare velocity, which is going to be used for player movement. Whereas current velocity will be used for interpolating in order to smooth out the movement. And finally dir will hold the input directions. Now I will declare some constants to be used for our calculations like speed, acceleration, etc. I have defined them as constants, but if you want you can set them as normal variables too and export them to inspector. All of these variables would make sense in just a minute. Now I will first reset direction every frame to a 0 vector, then update it by adding the camera's Z and X axes if a button is pressed, which basically means the direction we are looking at. Finally, we will normalize the direction vector. Now I will get the right speed and multiply it by direction, and this will give us our target velocity. With this, we will interpolate current velocity towards the target velocity and using acceleration as the factor. Then assign current velocity to velocity, and finally pass the velocity variable to move and slide. Also make sure to return the value to velocity itself, otherwise we will get some weird behavior. Now this seems to work fine. But as you might have noticed that we can move vertically too, which is something we don't want. And also let's implement gravity and jumping as well. Now let's declare some more variables. I will set gravity to -40 rather than -9.8, but you can choose any value you feel like. Whereas jump speed is the initial velocity when we start to jump, and jump counter is to limit the number of jumps we can do in mid-air. While air acceleration would simply delay the movement by a tiny bit while in mid-air. Now in every frame we will add gravity to the y component of the velocity vector. And if the player is on ground, then we set jump counter to 0. Finally, we would check if the jump button is pressed and the jump counter is less than 1. If the following conditions are true, we increase the jump counter by 1 and set velocity.y to the jump speed. Then we will get the acceleration value to be used based on whether we are on ground or not, and use it in the interpolation. Finally, to fix the vertical movement, We only assign x and z components of current velocity to velocity. Now here we go, we have created a basic FPS controller. In the next part of this video, we will be creating a weapon manager for our game. I hope this video was helpful and I will see you in the next part.